In layer 3, we have an address to identify a device. In layer 2 also we have an address to identify a device. Now, in which the layer 3 address is using a protocol called IP to identify a device. That's why we call that address itself as an IP address. An address that uses the protocol, internet protocol, to identify a device. We name it as IP address because the protocol only uses that address to identify. Now this IP address, we call it as layer 3 address. Again, the same reason, the protocol IP works in layer 3. Network layer, right? Layer 3 is network layer. Network layer is layer 3. And the protocol, internet protocol, works in network layer. Now this internet protocol needs an ID to identify a device. That ID is 32-bit size, binary bit size. We call it as IP address. This address is a logical address. Why do we call this logical address? This address, we can give anything. When you are in home, your home access point, the wireless access point, which is enabled with a service called DHCP, will throw you an address, will provide you an address. So your laptop, let's say it gets an address 10001. Now when the same laptop moves to office and connect to office network, that's going to give you 172.16.1.1. See, your laptop is now identified differently. In office, one address, in home, another address. That's why we call IP address as logical identity, logical address. Like my name, some people call me Aaron. When they call me Aaron, it's me only. Some people call Jay. That is also me. Some people call with my father's name. In abroad, they don't call my name. They call me using my father's name, my second name, my last name. But that also means me. But the fingerprint, my thumb has got a fingerprint. Every finger has got a fingerprint. That is same for J or Aaron or any name of mine, which people call me. The fingerprint is same. Likewise, the data link layer address. Data link layer is what? Layer 2. This address, which is called MAC address, it's the same address. When you are in office, 172.16.1.1 is your IP. The time MAC address is same as what you had in your home when the IP address was 10.0.0.1. So the layer 3 address, we call it as logical address. Layer 2 address, we call it as physical address. Because this never changes. MAC address, physical address, hardware address, that's another name. hardware address. Burnt in address. See, in some book they will write like this: BIA. BIA to identify, BIA to identify. You will be confused. What is this BIA? Is it something related to BIOS? B. Sometimes we get confused when they don't write it proper. BIA means burnt in address, means permanent address. Burnt in address. Hardware address, physical address, MAC address. This 4 thing means the same thing. Layer 2 address. Now this MAC address is 48-bit size. IP address is 32-bit size. MAC address is 48-bit size. But when we write an address, we don't write in binary. We write like this: 10 dot, 20 dot. We write in decimal. The 32-bit we convert into decimal and we write. Same way, if you take a MAC address, it is not written in binary, but it is written in hexadecimal. Very important. Here we write in decimal. Here we write in hexadecimal. You will see A, B, C, D, E, F. Just for example, I am writing 01, 0C, 09. Alright, so this is the example for MAC address. You will have 12 numbers, 12 digit hexadecimal. This 12 digits is equal to 48-bit binary. Here you have 4 numbers, 32-bit. We'll see how the conversion and all later. How can this 48-bit become 12 hexabit? We'll discuss those things a bit later. But now what we are going to take from here is, every device have got this 2 identification. One, not the permanent one. It is not the permanent one. We call it as logical address, layer 3 address. And it is 32-bit size. And it is called as IP address because the protocol called Internet Protocol needs this address, uses this address. Next is data link layer, which is layer 2 address. This is called as MAC address. Why? This address is to identify the media via which you are going to communicate. Understand this. Right now you may be using a laptop like mine. This laptop can communicate over a Ethernet wire, and also it can communicate via Wi-Fi. So I have 2 media. My laptop has got 2 media to communicate. One through wire, another wireless. Each media has got a MAC address. So how many MAC address my laptop will have now? 2. But which one is active now? Wireless. I have not connected a physical cable to that NIC card, network interface card, the port. I have not connected any cable. So that MAC address will not be active. Every media in your laptop will have a unique MAC address. And that MAC address is only on your device, no other device on the earth. You can see that it's only for you, unique. Media access control address, MAC address. Media access control. MAC address is 48-bit size, 48 binary bit size. Media access control. That's the name, media, because it is talking about whether to use Wi-Fi or to use the media Ethernet. And it is 48-bit size, written in hexadecimal, so it is in 12-digit. Various names we have, other than MAC address, we have another name, physical address, hardware address, burnt-in address, etc. Okay, what next? Now we are going to get deep into this MAC address, sorry, IP address. IP address. This topic is important. The size of IP addresses, can you say? The size of IP addresses? I think you are in mute. Well done. It is 32-bit, well said. It is 32-bit size address, but it is a binary 32-bit. We don't use binaries, right? In our day-to-day life, we don't use binary. So, this 32-bit need to be converted into decimal and used. For that, what they did is, first of all, they divided that 32 into 4 equal groups. Then how many bits will be in one group? 32 divided by 4 is 8. So you got 8-bit. Like this. The 32-bit is broken into 4 equal parts. We call this as octet. You know the reason why. Because you have 8. Octa. 8 bits. Octet. So how many octets we have in IP address? 4 octets. This is 1, 2, 3, 4 octet. IP address is 4 octet. Each octet is separated by a dot. Now, because the number of bits in each group is same, if you understand this one, it's the same thing for this and this and this. Am I right? Because all have the same 8-bit. If you understand how this 8-bit is converted into decimal, then you will know how to convert the other 8 bits. Now, we are going to understand how this 8-bit can be converted into decimal so that you can write IP address like this: 110.15.4.10. Here we need to know how to convert that binary into decimal so that you can have an IP address like this. So what I'll do is I'll draw 8-bit here. 1, 2, 3, 4, 5, 6, 7, 8. So I've drawn 8-bit here. The reason is we have 8 binary bits in each octet. We are going to understand how an octet is designed, structured, and how the conversion happens, so on. Now, because it is binary, that number system has got only 2 fresh numbers. I'm using a word, fresh numbers. How many fresh numbers are in decimal? See, we are using decimal from our childhood now. Try to answer this. How many fresh numbers are in decimal?
2, 0 and 1.
I'm talking about decimal. Not binary. I'm talking about decimal.
So 120 or 129.
Correct. So the fresh numbers in decimal is 0 to 9. This number is not a fresh number. Why? It uses this 2 here. So that is not a fresh number. Decimal has got only 0 to 9. Totally 10. That's why we call this decadecimal. In our school days, we might have done this. 2026. 6 multiplied by 10 to the power of 0. 2 multiplied by 10 to the power of 1. 0 multiplied by 10 to the power of 2. 2 multiplied by 10 to the power of 3. And we wrote answer like anything power 0 is 1. 1 multiplied by 6 is 6. 10 to the power of 1 is 10. 10 multiplied by 2 is 20. 10 to the power of 2 is 100. 100 multiplied by 0 is 0. 10 to the power of 3 is 1000. 1000 multiplied by 2 is 2000. Now when we add, we get 2026, the same number. So the reason why we put here 10 is decimal. And because it's in the 0th place, we put 0 here. First place, we put 1 here. This part, we have done this. You're comfortable with this, right?
Yes, sir.
Okay. Now, similar approach I'm going to now use for binary. Binary, fresh number is only 2. If I want to write 3, I will say 1, 1. So if I want to write 2, I'll say 1, 0. 3, I'll say 1, 1. So all the big numbers are made out of just 2 numbers. So now if I have 1, 1, 1, 1, 1, 1, 1, 1 here, what exactly it is? This is it. Why do I put 2 here? Because it is binary, not decimal. Earlier we put 10 because it was decimal. Now I put 2 here because it is binary. Why I put 0 here? Because it is in the 0th place. first place, so I put 1 here. For this one, I put 2 because it's in the second place. Now, face values. The face value of this is 2 to the power of 0 is 1. 1 multiplied by 1 is 1. So I'll write on here the face value is 1. 2 to the power of 1 is 2. 2 ones are 2. So the face value of this is 2. 2 to the power of 2 is 4. 4 multiplied by 1 is 4. So the face value of this is 4. 2 to the power of 3 is 8. 8 multiplied by 1 is 8. So this value is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. 2 to the power of 6 is 64. 2 to the power of 7 is 128. 16, 32, 64, 128. Now we have the face values of each places. 1's place, 10th place, 100th place. You have the values. Now when all these bits are 1, what is the value you get? You add and see, you will get 255. So far good, is it clear?
Yes, sir. This is clear.
Okay, now we move on to the next level. If in case this bit is 0, this is 0, this is 0, which means this is cancelled. 255 minus 32. 255 minus 32. That is the value. So what I'm trying to say is, if you will have all ones, it is 255, and we learned how it is 255. If some bits are 0, only then we need to do some calculation. If all are 1, 255. If I have 1, 1, 1, 1, 0, 0, 0, 0, what is the value? I need to add these 4 bit, because those 4 bit has got 1, which is 240. You know how I got this 240? I can add this 4 number, 128 plus 64 plus 32 plus 16, or total is 255 minus this one. This is 15. 255 minus 15 is 240. Do you understand this? Shall I give you some exercise?
Yes, please, sir.
Okay. 1, 1, 1, 1, 1, 1, 0, 0.
Okay, let me answer. 255. 252.
Correct. 255 minus 3 is 252.
252.
So 2 ways you can get this, either by adding all this
All or
or
exclude 3.
exclude 3 from 255.
Yes.
Let us do few more.
Yes.
1, 1, 1, 1, 0, 0, 1, 1.
Okay, let me do it. 8, 4, 12. 243.
Correct. So we already found 1, 240 up to here, and this is 3, 243. It is better to remember if this 4 are on 240.
Okay.
If this 4 are on, it is 15.
15.
Yeah? 15.
Okay.
Now, if these 2 are on, it is 192.
Okay.
128 plus 64 is 192.
192.
If these 3 are on, 224.
Okay.
I always remember this, so for me it becomes easy. And if this 5 are on, it is 248.
Okay.
Yeah, okay now?
Okay, sir. Fine, sir.
Okay, I'm going to give you some. You ready? Okay.
Yes, sir.
11000111.
Okay. 1, 2, 32, 16, 8, 56. Is it 199?
Very correct. Very nice. But easy ways. I told you these two, if it is 1, it is 192. And this is 7. 192 plus 7 is 199.
Okay. I have to keep remember.
Yeah. Then
It will be easy.
I was telling you here, if you remember, oh, it has gone actually. If you remember this, if first 2 is on, 192. If first 3 is on, 224.
1, 2, 4.
Okay.
Okay.
If first 3 is on, 224. So now I'm going to ask you, what is the value? 224 plus 15. You can do like that,
2, 4.
or what is the total value? 255 minus this value is 32. Sorry, this
32.
value is
Yeah.
16, 16, 16.
Um,
16.
4. This
255
is
minus
16.
16.
Yes. Yes.
255 minus
16. So which is means 149.
148. 248.
Sorry. 248. Sorry.
Is it
15,
248 or
16.
252?
16.
255 minus 16.
Yeah, 255 minus 16. So, which means 149 only, right?
Correct.
Sorry,
249.
249.
Yep. Okay. So that is how you can do. Or 224 plus 15. 9, 3, 2. It is 39. Correct. We already gave 1, no? So 4 minus 1 is 3.
So 4 minus 3. Oh, sorry. I mentioned 4.
239. Yeah. Either you do this way or that way. This
Okay.
is subtraction. This is addition.
Okay.
Okay. I'll give you a few more.
Yes, please, sir. Okay. This is 192.
No. 4 bits are odd.
First to four. First four means I mentioned something. Once again, 192 plus 16, 208.
No, 240. 4 bits are odd, it is 240.
Okay,
3 bits are odd,
three.
224.
Oh, 224. Okay,
This
okay.
is
I
240.
calculated 192. Yeah.
220.
224 plus 16 is like 240.
Okay. Shall I give you 2 more?
Yeah, one more.
One
Yes,
more?
please.
Okay.
Okay. 255 minus 128.
Hmm.
7, 2, 127.
You know the easy way I'll tell you.
Yes, please.
What is the value of this one?
128.
The sum of this will be 1 less than this. The sum of this will be 1 less than the value of this. If this is 128, then addition of this will be 127. You understood?
Okay, got it. Yeah.
Now, try to answer this.
Okay, this is sum of 32 till 1.
What is the value of this one? 64.
53.
No, no, this one, this place.
Okay, that is 64.
Which means it is 63. Sum
Oh,
of this will be
okay.
63. You understood?
Okay,
Now
got it.
let me ask you one more. I think I made a mistake. I put one here. Okay, now I'll
One
give
more.
you one more. What is the value of this one?
16. So 15.
Exactly. You try
Okay.
adding this. 8 plus 4
Yeah.
plus 2 plus what? 15.
15.
You understood?
Okay.
Now,
Yeah, got
this
it.
knowledge is important for you when we do a topic called subnetting.
Okay.